So this is pretty trivial. This has to be true. So the second thing we need to compare is whether the derivatives are going to be equal or not. So let's try to find the derivative of PA first. So if we take the derivative, this is fairly easy. So we have 50,000 times 0.08, and then we have negative 1 over I squared. And then we plus $35,000, 1.08 to the power of 5. And then we take this derivative, which gives us negative 5, 1 plus I to the power of negative 6. So this is going to be the expression for the first derivative. And then we do the exact same thing for PL. And this is going to be fairly straightforward as well. So we're just differentiating this, the I is at the bottom here. So we have $85,000, and then times 1.08 to the power of 10, and then put the negative 10, 1 plus I to the power of negative 11. So this is the derivative of P and PL. So now we need to determine whether both of these are equal or not. And then instead of comparing this directly, I'm going to change change what we're comparing slightly. I'm going to compare the volatilities instead, and I'm doing this just to test your concepts, because what you need to keep in mind is that the volatility is just the negative of PAI divided by PAI. And so same for the liability part. This is essentially what it is. So I'm going to use this number instead. So this is to help you keep in mind that the concept of a volatility is really just the derivative as well. So we can instead of comparing the first derivative, we can also compare the volatilities. So during the exam, if you're asked to immunize something and then you're given the volatility, you can actually use the volatility. So if you calculate these two expressions at 8%, so at I equal to 8%, you'll find that the volatility of A is equal to 9.2593, and as the same thing goes for the volatility of L. So you see that indeed both of them are the same. So this second condition is also satisfied. So now we move on to the third condition. We want the second derivative of the asset has to be larger than the second derivative of the liability. So in order to do this, we take the derivative once more. So the second derivative of asset, it's really just rather simple. So 0.08, and then we have 2, and then I to the power of negative 3. And then for this other term over here, we have $35,000, and then times 5, 1.08 to the power of 5, and then this 6 goes down here, and then it cancels out with this negative sign here, so we have 6, 1 plus I to the power of negative 7. And we do the exact same thing for the liability again. So it's just really just pulling the negative 11 down here and then changing this to negative 12. So we have 85,000 times 10 times 11 times 1.08 to the power of 10, 1 plus I, negative 12. And then once again, we substitute I equals to 0.08. We want to know whether we can achieve immunization now. And then once again, I'm not going to compare these terms directly. Now I'm going to compare, so just to test your concepts, we're going to compare the convexity of A and the liability. And the reason is, once again, to remind yourselves that the convexity is really just the second derivative divided by PA. So once again, if you're not given the second derivative, you can also use the convexity. So that's why these terms are, the convexity is an important concept. And so once you calculate the convexities of these expressions at 8%, you'll find that the convexity of the asset is equal to 196.18. The convexity of the liability is 94.31. And then indeed, this is larger than this. So that's why this third condition is also satisfied. So the conclusion is we can achieve immunization through this strategy over here.